Alright, let's get going on this first lesson. Right now we're going to expand and simplify some algebraic expressions. Now you might be wondering, what does expanding have to do with factoring? I promise you, the answer is very simple, and I will say the answer at the end of this video. So let's brush up on some algebra. This is our first example, and you can see here that we are going to expand and simplify a binomial times another binomial. So you may have seen this in class or in a book referred to as FOIL. FOIL is an acronym that stands for first times first, outside times outside, inside times inside, and last times last. Now, that sounds fine to catalog it like that, but what if you had more than two terms? So for this reason, I prefer to say distributive property or distribute. So I will use the word distribute in questions involving expansions. The reason is really it applies to a more general situation. But if you use FOIL, it's just fine. So let's go. X times x gives us x squared. X times 5 gives us 5x. Notice that x has had the opportunity to multiply by all of the terms in the second bracket. So basically, x is done. We can go over now and multiply or distribute the 2 throughout this bracket. So let's take a look here. We have 2 times x is 2x, and 2 times 5 is 10. Do you notice that there are some terms that are similar? Well, they're right there. 2x and 5x. So since they are like terms, we can write it as x squared plus 7x plus 10. And really, this is the heart of what you're doing in the distributive property and its applications. So that seemed pretty simple to start with, and hopefully you didn't have too much of a challenge with it. So let's do a bunch of examples where we can turn it up a notch. Okay, so in this case, the coefficients on the x are not 1 anymore. So it just means you have to do more multiplication. So again, pause the video, try this on your own, and if you need some support, you can press play and see what I did. Here we go. Let's distribute the 3x times the 2x and the 7x. So 3x times 2x is 6x squared, and 3x times 7 is 21x. And then we can distribute the 2 by everybody. See, 2 times 2x, there's the 4x, and 2 times 7, 14. Do you notice that there's a nice structure to this? We have x squared here, and then we have x terms here, and then finally we have a constant term at the end. So the reason this occurs is because the terms are all nice and organized in the original brackets. So it's very quick for us to just kind of collect those like terms here. So here we have 21x and 4x, so that's 25x. Finally, we have a 14 here at the end. So that's a binomial times a binomial. What if we had more than just that in the question? Don't panic. Here we go. So, okay, we got one of those, okay, and then we got another one over here. So you're probably like, okay, wait a second, this is a little bit out of control. But really, can't you just divide and conquer this? Why don't you just do this question first, and then do that question after, and then put them all together? Try that. Let's do it. So I will distribute the 2x times the x and the 5. So that gives us 2x squared and 5x. I should say 10x actually. And then we have the 3x and the 3 times the 5. So that basically completes the first part of this question. I could write the second part in orange. Just looks a little cool and you can catalog it better. So let's do this 3x times 4x. And what do you get there? 12x squared. And finally, we have a 3x times a 7, which is a 21x. And we can distribute the 1 across. 1's my favorite because when you multiply by 1, you basically just copy the expression. So 1 times this whole thing is just that whole thing. So 4x and 7. Okay. So now it's a matter of organizing it. So you can say, okay, where are the like terms? Oh, there's a 2x squared here, and there's a 12x squared there, and you can put them all together. And that's exactly what I would do. So some people get all colorful, including me, but what if we just kind of, are in a test situation? You can't sit there coloring all these things. You're going to run out of time, right? So this is what I do. I just underline things. Notice that when I underline a term like 12x squared, I underline the plus sign, because the plus sign belongs to the 12x squared. And that helps you organize yourself. So here we have 2x squared and 12x squared. So you have a 14x squared. Now you have a bunch of terms that involve x. Let's underline them differently so that, again, you don't want to pull out your highlighters in the middle of a test, although you are more than welcome to. My big thing when I was writing tests was trying to finish it fast because I wanted to go eat my lunch. But, you want to be very careful when you do things. So anyway, here we go. Let's catalog and add these all up. So we have 10 and 3 and 21 and 4. So this is 13 and that's 25. So 13 and 25 is 38 x's. And finally, well, do you need to really decorate these ones? No, they're on their own anyway, so just leave them like that. So 15 plus 7 is 22. And that pretty much takes this question down. I think that you've made a good start if you've gone through these first few examples without too much stress. So, what's different here? By doing these examples, I want to show you that just adding a little bit extra each time is really getting to where the point where you can identify and kind of predict what's going to happen next. I found that I was most successful in performing in tests and figuring out problems when I thought about what would be the next thing that could happen so that it could be more difficult. So here we go. I hope you don't mind me throwing advice at you as I'm doing these videos, because a lot of the times I really enjoy just talking about philosophy of learning and strategies for success, and maybe I'll make some videos on that soon depending on your feedback. So here we go. We're going to take this binomial here and multiply by that binomial there. This 4 here, I'm not going to deal with it now. Put it on the side. You can think of it as a spectator kind of watching the show. So let's take this x and multiply by that x, and you get your x squared. And the x times the 3 gives us a 3x. Now we can work on the negative 2. See this negative 2? It's been waiting to multiply some stuff. Because the x is finished, we can deal with the negative 2 now. So negative 2 times x is literally negative 2x. You just put them together, you concatenate them, and then you have negative 2 times 3, which is negative 6. Here we go again with another binomial. Maybe I'll do this one in a different color so you can organize it better. Here we have 2x times x, so that's 2x squared, and a 2x times the 5, which is 10x. Now I think that we've completely exhausted the 2x and we can move on to the 3a. So 3 times x and 3 times 5. So that would give us 3x. What happened there? 3x and 15. So, time to collect like terms. But wait, we have a 4 here. So what you can do is deal with that 4 first. So here we go. 4x squared plus 12x minus 8x minus 24. Now what about this stuff over here? I mean, you could add those up and get 13x. But allow me to show you something tricky that I do. I have the magic of copying and pasting here, so I'm just going to do that. Is your mind blown? Is that something you thought of before? These are the little tricks and things that I used to do to save time on my tests, because these all line up nicely with those. So what's 4x squared and 2x squared? Just line them up and add them. 6x squared. Okay, these guys are all the same. They're all like, I should say. So, whoops, I don't know what happened there. I glitched a bit. So, probably take me more time drawing this circle than it would to just answer the question. My computer's a little glitchy, I see. So here we go. 12 minus 8 is 4. 10 plus 3 is 13. So that would gives us 4 plus 13 is 17x. And this guy over here, that's a negative 9. And that is your question. That is the expanded and simplified form for this very long expansion. So I want you to think about what can make this question worse. Well, I think that if I toss in a negative sign perhaps here, that would really make your life miserable. So let's do that. There you go. Here's a minus sign. But we can still approach the question in the same manner that we did earlier. We can expand these guys here, and then expand those guys there. And once those terms are all expanded, we can collect the like terms and finish it up. So if we distribute the x times those, x plus 3 terms, we get x squared plus 3x. And finally, we have the 5 times the x and the 5 times the 3. 5 times x is literally 5x, and 5 times 3 is 15. Okay, this negative sign's probably going to screw you up, and it would probably screw me up if I was in high school still. So let's just put the negative aside and deal with it later. And remember, the negative means negative 1. If you want to put the 1 there, it's fine. There is no shame in writing that 1. So here we go. 2x times x is 2x squared. 2x times 9 is 18x. And 5x is right there. And 5 times 9 is 45. So the idea is that you have seen this probably before. So if you see me doing little gymnastics in the question, cutting corners, or not necessarily cutting corners, but just organizing it slightly differently, it's for me to challenge you to see things at a higher level. So these are some of the things that you can do. The 5x and the 3x, you might as well just collect them together at this point instead of writing them down twice. You might not have the option of copying and pasting like I did on the previous example. Now, here we have a negative 1 that is going to distribute and basically switch all the signs of those terms. So for example, 2x squared times negative 1. Negative 2x squared. 18 and 5 is 23x, but you put a negative because it's multiplied by negative 1. And finally, we have negative 1 times 45, which is negative 45. Now you could go there and underline them and highlight them and whatever you need to do and collect them. I'll do the same here. I won't do any copying and pasting this time. Just keep in mind here, the negative belongs to the 2x squared. So here we have x squared and here we have minus 2x squared. There is an understood 1 there in front of the x squared. So 1 minus 2 is negative 1. Although I will not present a negative 1 here, it is fine if you do. Just try to do it less and less over time because it looks a little bit basic. Okay, let's take those terms that are linear with the x and combine them. We have an 8 and a negative 23, which if you add those together, you get negative 15. And finally, you have a constant term here, which is a 15, and a negative 45. So that gives you the negative 30 here at the end. And if you're wondering, I'm peeking at my final answers because I'm trying to do this all in one take. So here we go with the next one. Yikes. Okay, now you're probably thinking, what the heck do I do here? What the heck does this square mean? Well, are you familiar with the term copy and paste? Because when you have an expression with a squared on it, that's exactly what you do. You copy and paste. And you know what? Just for entertainment, I'm going to copy and paste it. As an engineer, I always find things to do to keep myself amused. and that's one of them, is leveraging technology to save me some time. All right, here we go. X minus 4. Should I? Yeah, okay. I'll just write it this time. Let's see how consistent the handwriting is. Okay, so I can forge myself. All right. Let's do this one like the previous question now. So remember, with a squared here, you just copy it twice. Or what if it was cubed? Well, you'd probably be there for 10 minutes. I'd probably be there for a few minutes. And would not be very happy if that was on a test. So what we're going to do now is distribute this binomial by that binomial and those binomials here. Because they're separated by minus sign, I recommend the following template for the second expansion, like that. So we have 2x times 2x, which is 4x squared. And then we have 2x times 3 is 6x. And 3 times 2x, which is 6x. And finally 3 times 3, which is 9. Did I squeeze it in? There we go. All right, let's expand this one out. Oops, I can just catalog that there. So we have x times x is x squared. X times negative 4 is negative 4x. Finally, we have the second pair, which is negative 4x. And of course, what's a negative times a negative? It sure as heck is a positive, right? There we go. Okay. So we have 4x squared. I'm just going to copy that down, actually. These guys here are like terms. That's 12x. And we have a 9 here at the end. Now, with this second bracket, I should mention that we have a minus in front. And when you multiply the minus throughout or distribute, it's going to switch the sign on all the terms. So what's a minus times x squared? It's minus x squared. And you know what? I'm going to have some fun here. I'm going to put it down here because I like to save time and organize myself. Here we have negative 4x and negative 4x. That's negative 8x. If you multiply negative 8x by negative 1, you get positive 8x. Look at that. And finally, you have a 16 multiplied by a negative 1, which is negative 16. So 4x squared minus x squared is 3x squared. And I'll just say the numbers. It's 12 plus 8, that's 20, so 20x. And 9 and negative 16 is negative 7. Wow. It is going to happen in one take. Let's see this. Okay. Oh, words. Wait a second. This is supposed to be like algebra. Algebraic slavery. No. Well, you need to understand how to read a question. And don't get scared, because this question looks really, really scary. It's got all these words, and maybe you're going to make a mistake reading it. I'll just tell you this. I am a very slow reader. But when it comes to math and science, you can just slice through those questions because all you got to do is read the keywords. So let's see here. Blah, 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 expanded. Blah, 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 area. What else? Oh, the shape here, rectangle. What's a rectangle look like? Draw a rectangle. Here you go. X plus 7, x plus 3. Now, if you feel that there's more keywords that you need in there, that's fine, but I like to do the bare minimum. So here we go. It says find an expanded expression for the area. So this is a rectangle. What's the area of a rectangle? I'll just jot that up here. Area is length times width. I don't like putting a times symbol. Can you imagine the controversy there? The reason is a times symbol doesn't look really like an X. So try to shy away from using the times symbol in algebraic expressions, even when an X is not present, unless of course you are typing it up. So here, the area, and again, you don't have to declare this variable here, area, because the expression is sufficient. It's not asking for a formula. So we have x plus 7 times x plus 3. Now, this expression is correct, but it doesn't satisfy the condition of being expanded. So yeah, you got to expand it. So I'll do that in orange, just so that you can correlate between the question and the answer. So, wow, this is a lot easier than it looks now. You're not doing, look at this example here. Look at all that stuff. This is just a simple FOIL, or distribution. So let's do that. X times x, x squared. X times 3, 3x. And finally, 7 times x is 7x. And we have 7 times 3 is 21. I will do some very creative things with my organization in algebra as I go through the many different lessons that I plan on showing here. And I hope that you appreciate them. I'm not trying to do them to make myself look cool. They're just things that I found really save me time, and I didn't screw them up on tests, which is really important. Oh, so what is factoring? Alright, I'm not going to get into any TED Talk speeches here or anything fancy or whatever. I'm just going to tell you flat out what factoring is. Factoring is the opposite of expanding. Here, let me highlight it to sound really, really cool. Opposite of expanding. Okay? So, if you took all the questions that we just did and played them in reverse, if you could play my words in reverse, that would be factoring. Looks like I dropped the ball at the end and I didn't get to actually do this in one take. Let's take a look at a couple of the questions where I can show you how expanding and factoring are related. So these two questions here are actually related. See, if I expand or distribute the 3 in this expression, I get 3x and 6. And what do you see here? Oh, you just see the expression that I wrote. So factoring really is just writing the steps to this process backwards. So 3 times x plus 2 would be the answer to the second question. And that's how simple it is. Well, I mean, if you have all the steps shown to you. And what we're going to do in the future lessons is look at how you actually reverse that process, not for this easier stuff, but for more advanced stuff as well. Here's another one just to wrap up this first lesson. Let's expand out the 10 into the, let's distribute the 10 into this bracket here. We would have 10 times x squared, which is 10x squared, and then 10 times 2, which is 20. And that is identical to this expression. So to factor would be to do the opposite. And that would result in the original expression that started off with this particular example. And that's it. So let's take a look at several of the techniques for factoring over the next videos and see how we can escalate to some more advanced questions, and by the end of it, hopefully get your confidence ready so that you can kick the crap out of your factoring test.